Given question, find the equation of motion for the given system.
Let us understand given system. Two combined disks are pivoted about the center at point O. The outer disk with radius R2 is connected to the element spring with stiffness K1, mass M1 and the dashpot with damping coefficient C, while the inside disk with radius R1 is connected to the mass M2 and the spring with stiffness K2. We will first find out the differential equation of motion by the free body diagram method. We will consider here this disk rotated about the center O through an angle theta. So we will show this with the help of diagram. So I will consider the point A on this outside disk and point B on the inside disk. And here is the rotation through an angle theta. So what is the final position of this A? That is A dash. And final position of B is B dash. Now if I draw here one perpendicular line from this A dash on the line OA, then this distance will give us the linear displacement. So I will say here point of intersection as a P. So this linear displacement we will say X for this outer disk. Now for the inside disk I will draw one perpendicular line from B dash on this line O to B, and this point of intersection I will say Q. So B dash to Q we will say this linear displacement as a x1. So there are two displacement for this outer disk and the inside disk. Now if this disk is rotating in anti-clockwise direction through an angle theta, then there is the accelerating torque or accelerating couple develops. We will consider the mass moment of inertia for this combined disk will be I. So what is that accelerating couple? So accelerating couple is I theta double dot, and its a direction is in the same direction of the theta, that is in the anti-clockwise direction. Now this accelerating couple is getting balanced by the external couple due to external forces. Now which are those forces? These forces are developed due to these external elements, that is spring with stiffness K1, masses M1 and M2, spring with stiffness K2 and this dashpot with damping coefficient C. So we have to first find out the direction of the forces. So if we observe here the direction of X, that is the initial position of this point P is here and the final position is A dash. So direction of X is towards the left hand side. Now if we observe in the same way the direction of X1, so initial position is B and then it is B dash. So B and Q are very small distance, so we can say that this x1 is also having direction towards the left hand side. Now this mass m1 and this damper C is connected through a string. So if we observe this x is towards the left hand side, direction is left hand side, so it is connected through the string for this disc, or we can say pulley. So its a direction is in the downward direction. So direction of the displacement is in the downward direction and displacement is x for the outer disc. Now why it is in the downward direction? Because if we observe the center, these elements are placed on the left hand side of the center, and that's why it will move in the downward direction. And now if we observe for the displacement for this inside disc, so inside disc elements are M2 and the spring with stiffness K2. Now these two elements are on the right hand side about center O, and this disc is moving in anti-clockwise direction, and that's why these elements will move in the upward direction. So what is the linear displacement here? Linear displacement is x1. So we have to show here for the inside disc, here is the x1, that is in the upward direction because the disc is moving in anti-clockwise direction. Now we will find out the forces. Now because of this mass m1, the accelerating force will develop and it will act in the same direction of the displacement. So m1 is having accelerating force in the downward direction and it is m1 multiplied by acceleration. So displacement is x, so acceleration is x double dot. Now what about this damper? So damper force is in the opposite direction to the displacement. So this damper force Fd will act in the upward direction. So I will show here. It is in the opposite direction of the motion. So Fd will act in the upward direction. Now what about mass m2? So it is the acceleration force develops and it is in the same direction of the displacement, that is in the upward direction. And what is its value? m2 multiplied by acceleration. So here displacement is x1, so acceleration is x1 double dot. Now what about spring force K2? So spring force K2 will act in the opposite direction of the displacement. So spring force with Fs2 will act in the downward direction. So I will show here Fs2, that is the, because stiffness is K2, so I will say spring force Fs2. Now we will move here the other element, that is stiffness K1. So here spring force Fs1. Now if we observe, the motion is towards left hand side. So spring force will act in the opposite direction of the motion. So Fs1 is having direction towards the right hand side. So these are the external forces. So 1, 2, 3, 4, 5. 5 external forces are there. So this accelerating couple is getting balanced by the external couple. So we have to find out the external couples. Now we will first find out the relation in between linear displacement and angular displacement. If we observe the triangle OPA', then from this triangle we can say that x is equal to, this O to A' is R2, that is R2 sin theta, but theta is very small, so we can write here x is equal to R2 theta. Now in the same way, in the triangle OB'Q, here O to B' is R1. So we can say that x1 is equal to this O to B', that is R1 sin theta, but we can say that R1 theta because theta is very small. Now we will understand how to decide the direction for this external couple. So first is the acceleration couple, that is I theta double dot. So I will write here first I theta double dot and its direction is anti-clockwise direction. So it depends on the direction for this theta. Now we will move to the next. So next is the couple due to this acceleration force m1 x double dot. So I will write here this force is m1 x double dot. Now how to find out the couple? So couple is this force multiplied by perpendicular distance. So perpendicular distance from point O is equal to R2. So this force multiplied by R2 will give us couple. Now how to decide its a direction? So this force is having downward direction. So I will move the compass about the point O in the downward direction. So if I move, then we will get the anti-clockwise direction. So I will show here, this is the anti-clockwise direction. Now we will move next, that is for this damper force Fd. So how to decide this damper force Fd, that is damping coefficient multiplied by the velocity due to displacement x. So Fd is equal to, so first I will write the formula for Fd. So Fd is equal to damping coefficient c multiplied by velocity due to x is x dot. So c into x dot. Now how to find out the couple? So this force multiplied by perpendicular distance. So perpendicular distance is R2 because it is connected to outer disk. So I will write here c into x dot multiplied by R2. Now how to decide its a direction? So if I move the compass in the upward direction about point O, that is in clockwise direction. So we have to show here This is the clockwise direction. Now we will move next, that is for mass m2. So again there is the acceleration force m2 x1 double dot. So this is the force multiplied by perpendicular distance. So perpendicular distance is r1 because it is connected to the inside disk. So this is the force. Now force multiplied by perpendicular distance, that is, this is the couple. Now how to decide its direction? So this m2 x1 dot is having upward direction. So I move the compass in the upward direction. So it will give us anti-clockwise direction. Now we will move to the spring force, that is Fs2. So how to define this Fs2? That is the stiffness multiplied by displacement. So I will write here Fs2. So I will write with the red marker. Fs2 is equal to K2 and displacement is x1. So I will write K2 x1. Now here, how to find out the couple? So this force multiplied by perpendicular distance is r1. So we will say here couple is K2 x1 multiplied by r1. Now we have to decide its direction. So Fs2 is having downward direction. I will move the compass in the downward direction. We will get the clockwise direction. Now we will move the external force due to this stiffness K1. So again, what is this Fs1? So Fs1 is stiffness multiplied by displacement. So it is connected to the outer disk which is having displacement x. So Fs1 is equal to this K1 multiplied by x. And couple, how to find out this perpendicular distance? That is force multiplied by perpendicular distance. That is K1x is force. Perpendicular distance is r1. And what is its direction? So I will move the compass in the direction of Fs1. So if I move the compass about O, then we will get the clockwise direction. So these are the directions and the couples. Now we will observe the direction. So some one are in anti-clockwise direction and some couples are in clockwise direction. So suppose for anti-clockwise direction we will consider negative sign. So I will consider the negative sign for anti-clockwise direction. Then for clockwise direction we have to consider positive sign. One important point to note that the accelerating couple develops due to mass moment of inertia for this combined disk, that is I. Then the accelerating force due to this mass m1 and the accelerating force due to this mass m2. So we have to take all these accelerating couples on the left hand side, that is I theta double dot, then this m1 x double dot into r2 and this m2 x1 double dot into r1. So we have to take on the left hand side, and the couple due to external forces are due to forces of this damper force, spring force with K2 and spring force with K1. So we will write the equation as per the Newton's second law of motion. Accelerating couple is equal to summation of external couple. So if we observe the couple due to this mass moment of inertia, then this couple due to this masses m1 and m2 is having anti-clockwise direction. So we have to give here the negative sign. So minus I theta double dot minus m1 x double dot r2 minus m2 x1 double dot r1 is equal to. Now on the right hand side we will write the couple due to this damper and spring force. K1 x r2 plus K2 x1 r1 plus C x dot r2. Now all these couples are having clockwise direction. So we have to give here the positive signs. So this equation is important. So I will give here the equation number 1. Now we have to simplify this equation. So we have the relation in between this x as well as x1 and theta. So we know x is equal to r2 theta, x1 is equal to r1 theta. So we can say that theta is equal to x by r2 and which is equal to x1 by r1. Now to find out the differential equation we have required, that is x double dot, x dot and x. Now here we can replace this x1 double dot and x1 in terms of x because we have this relation. So how we can replace this x1? So we have to find out the value of x1 in terms of x. So from this we can write here x1 is equal to x into r1 by r2. So we have to put this relation instead of x1. So how we can write x1 double dot? So we will write here x1 double dot is equal to x double dot r1 by r2. So again we will write, now instead of this theta double dot we will also put the value in terms of x. So how to write here theta double dot? So we know that theta is equal to x by r2. So theta double dot is equal to x double dot by r2. So we will take here minus I x double dot by r2. So we have to replace this theta double dot. Then minus m1 x double dot r2 minus m2 x1 double dot. So this we have to replace this x1 double dot. Then r1. So instead of x1 double dot we will write x double dot, and here r1 is r1 square by r2 is equal to here k1x r2 plus k2 x1 r1. Now instead of x1 we will put the value of x, that is x r1 by r2. So here r1 multiplied by r1, that is r1 square. So k2 x r1 square by r2 plus c x dot r2. To find out the differential equation of motion, we will combine the coefficient of x double dot, x dot and x. So from this equation we can write here x double dot is having coefficient minus I by r2 minus m1 r2 minus m2 r1 square by r2. Bracket complete, and we have to give the coefficient x double dot. Now this x dot is having only one coefficient and it is on the right hand side. So is equal to cr2 x dot plus, now x is having coefficient k1 r2 plus k2 r1 square by r2, bracket complete x. Now we will take this term to the right hand side because it is having minus sign, and we can take this minus sign as a common term, and we will transfer this term to the right hand side and we will make the equation. So final equation of motion for this system is I by r2 plus m1 r2 plus m2 r1 square by r2 bracket complete x double dot plus cr2 x dot plus k1 r2 plus k2 r1 square by r2 bracket complete x is equal to 0.